Hi guys. Okay, I'm starting our first set of slides when we're talking about elimination and organ clearance. This is a concept that we'll use to talk about both renal and hepatic clearance as we get to those different organs of clearance. But these are just clearance concepts. Alright, so here we have our introduction. Alright, so our objectives are to be able to list how drugs may be eliminated from the body, identify the determinants of clearance, so we're going to go down that next level, define extraction efficiency, list its determinants, and predict what effect it will have on clearance at its extremes. We're going to talk about the jar and parallel tube models for clearance. You're going to be able to define intrinsic clearance, list its determinants, and predict what effect intrinsic clearance times fraction unbound will have on clearance at its extremes. Even more objectives. You'll be able to differentiate between blood, plasma, serum, and plasma water. You probably can already do that from being in anatomy and physiology. Describe the clinical value of understanding organ clearance and how it will affect dosing regimen choices. I think you already know how clearance will affect dosing regimen choices, don't you? I'm going to try something fancy here. Start a new page. Trying something new. Don't know if it'll work. Well, I guess it doesn't. All right. I'll figure that out. Okay. Oh, it's ready to run on here. Okay, cool. So what we know is if we want to make a dose rate change, we look at CSS average, don't we? CSS average is determined by bioavailable dose rate over clearance. Today we're talking about clearance, so we know that clearance is an important determinant of CSS average and therefore our determinant of how much drug we're going to give per time, or our dose rate. Our other part of our dosing regimen is our dose interval, or tau. We determine tau based upon our peak to trough ratio, right? Our peak to trough ratio is 1 over e to the negative k tau. So what we control here is tau, and k is determined by clearance over volume. Again, clearance is going to have changes in clearance are going to affect both our peak to trough ratio and our CSS average. Therefore, it's going to affect both our dose rate and our dose interval. So we know that this is going to be an important determinant. Okay, now I need to figure out how to move on. Oh, I'm learning. All right, first of all, how are drugs eliminated from the body? Well, there's two basic ways. The drug can either be metabolized. Now, when a drug is metabolized, that doesn't mean it flies out of the body. That means that it is changed into something new. So when it's changed into something new, it's in all intents and purposes gone then, isn't it? Because it is something new now. So there's two types of metabolism, chemical reactions that can happen in the body. It can be a phase 1 reaction, which is a non-synthetic reaction, and drugs are being changed to a more polar form. It's usually like hydroxylation, oxidation, reduction, pretty simple chemical changes that metabolize the drug and change it into something new. That drug that is something new will have its own properties, and it's called a metabolite. Phase 2 reactions are when you're sticking a bigger functional group onto the drug usually. So conjugation is usually a conjugation reaction, and a polar group is added to the molecule. In general, we're trying to get rid of drugs, and usually you're trying to actually move that molecule out in the urine. That's the easiest way out, right? Once it's been absorbed and everything. It can't go out in the poo anymore. It's now going to go out in the urine. There is a way for it to go out in the poo, but we'll talk about that later. It's going to go out in the urine. So urine is aqueous. So if we have a very nonpolar drug, we have to change it into something more polar so it can be removed by the urine. So that's in general what's happening with metabolism. Phase 2 reactions are catalyzed by specific enzymes, but not the P450 system, which is the most important catalyzing enzymatic system in the body. The P450 system is undergoes phase 1 metabolism, not phase 2. So drugs can either be metabolized or just excreted in the urine. So that would be the molecule moving through the body and out in the urine as is. And that's usually by renal clearance. So to be eliminated, a drug can either be metabolized or excreted. Okay, we talked about this already. I think I jumped the gun here. Phase 1 is oxidation, reduction, hydrolysis, which is usually, not always, but the P450 system is very involved in phase 1 metabolism. Phase 2, acetylation, transsulfuration, glucuronidation. These are not P450 systems. Sites of metabolism. There's tissue that can metabolize drug all over the body. The most important site is the liver. The liver is where most drugs are metabolized. But kidneys also have enzymes, and skin can metabolize. You can actually metabolize in the lung, blood, and of course we already know that there's enzymes in the GI wall that can metabolize drug, right? Excretion. Most drugs have to be altered before they can be eliminated because most drugs are fairly nonpolar in order to get absorbed. So they have to become more polar then to get out of the body. It's kind of tricky. Some drugs are eliminated unchanged from the body, usually through the kidneys, but also you can exhale the drugs through the lungs, or it can be secreted through the skin. That's it. All right, see you in the next one. Bye-bye.